Hey everybody. In this lesson we're going to talk about percentage composition. Basically the big idea here is that all species in a molecule takes up a percentage of their mass, and these percentages can give you the identity of the molecule. So in terms of percentage composition, it could apply to anything, but we're to talk about it in terms of molecules. Because a lot of times we talk about it in terms of, for example, body composition, what the human body is made up of. We talk about, for example, about what is the mass of a car and what are the different parts of it. Planets, what their percent composition of those planets are. The stars, what percent composition of those stars are. So there's a lot of different percent composition that we're going to discuss, but we're going to discuss in terms of, for this one, the molecule. So, percent composition it is the percentage by mass of each element in a compound. Okay. So, example, if you have Cl2, the carbon will take up a specific percentage of mass. Okay, so how do we find percentage composition then? Well, we assume we are dealing with 1 mole of our compound. So what do? Well, number one, find total molar mass of compound. Number two, find molar mass of each element. Number three, if more than one of an element, multiply mass by the number. Step 4, divide elemental molar mass by total molar mass times 100%. And this will give you your percentage composition. Now, to be neat, I usually say put it in a table because a table will allow you to see which element is what in that case. So our first compound we'll look at is MgNO32. So, first step, find the total molar mass of MgNO32. Well, if you look at this, Mg has a molar mass of 24.3 plus we have 2 nitrogens. So 2 nitrogens plus 28. And we have 6 oxygens. So we're going to add, in this case, 6. Oops. Let's go back. Oops, 53. 52.3 plus 6 times 16. It's going to give you 148. So the total molar mass of this compound is 148.3. Okay. So, what we have now here, this is the total molar mass. So now what we want to do is make a little table that will let us be neat. So first step is, I always label these tables this way. You don't have to follow the same way. But I always label the first one is the element. What is the element present? Well, we have magnesium, we have nitrogen, and we have oxygen. The next column on the right is the molar mass. What is the molar mass of each element? Okay, we're looking at this then. The molar mass of magnesium is 24.3. Okay, nitrogen is 14.0 and oxygen is 16.0. Next column is look at the number of each element. Okay, how many of each element do I have? Well, I have 1 magnesium, I have 2 nitrogen, and I have 6 oxygens. The next thing I have here is the total, or the mass of each element. Okay, which means it's the multiple. You take these two and you multiply them, equal that. Multiply them, it equals that. Multiply them, equal that. So what we have here is we have 24.3, 28, and in this case, this last one is 96.0. Okay, the last thing is percent, calculating the percent. We do this by taking our mass of each element and dividing by the total molar mass and multiplying by 100%. So here I have 24.3 divided by 148.3 times 100%. I get 16.4%. Now you should round to the 10th, 16.4%. 28 divided by 148.3 is going to give me, times 100%, it's going to give me 18.9%. The last one is 96. 96 divided by 148.3 equals, times 100% is 64.7. Okay. Now, how do you know if you did this correctly? Is when you add these percentages, they should be pretty much close to or at 100%. And what you're going to see is, alright, we're going to get 100% here. So this is the percent composition of MgNO32. We have 16.4% of this compound is magnesium, 18.9% is nitrogen, and 64.7% is oxygen. Let's look at our next example. So again, same thing as we did before, make a table to keep yourself neat. Okay, so what we have here is, we have each column's a different topic, or different term. Okay, so the first column is the element, then it's mass, molar mass, the number of it, the mass of it, and then the percentage. So what is the total molar mass of CrNO33? Well, let's take a look. So we have Cr, we have chromium, which is right here. That's 52. Oops, 52. Then we have our next element, which is 3 nitrogens, which is 42. And then we have 9 oxygens. So 9 oxygens. 9 times 16 mass of oxygen is, and we get a total molar mass of 238. Okay, let's go find them now. Chromium, molar mass is 54, I believe. Or 52. And there's 1 chromium, so it's just 52.0. We have nitrogen, which is 14.0, and there's 3 of them. That gives you a mass of 42.0. Oxygen, there is a mass of 16, and there's 9 of them, which gives you a mass of, in total of 144.0. Okay, so what is the percentage composition of each? Well, the first one is 52 divided by 238 times 100% is 21.8%. 21.8% of this compound is chromium. The next one is 42 divided by 238. I get 7 times 100, 17.6% of this is nitrogen. And the last one is 144 divided by 238 times 100%, and I get 60.5%. And again, to check, add these up. If they all up to 100%, you know you did this correctly. In this case, it adds a 99.9 because of our rounding error. But it's pretty much 100%. Okay, the last one. This is acetate, or acetic acid. Acetic acid has a total molar mass of, if I were to do this really quickly, 12 plus 3 plus 12 plus 32 plus 1. 60 grams. 60 grams per mole. What is the percentage composition of this chemical? Well, let's make our table. Let's put a title for each of these sections. This is element. This is molar mass. The number, the mass, and percentage. Okay, the elements we have present are carbon, hydrogen, and oxygen. The molar mass of carbon is 12.0. The molar mass of hydrogen is 1.0. And oxygen is still 16.0. There's 2 carbons here, there's 4 nitrogens, and there's 2 oxygens. So total mass here is 24.0, 4.0, and 32.0. So what would the percentage composition of each of these elements are? 24 divided by 60 gives you 40%. So 40% of this chemical is carbon. 4 divided by 60 is 0. Or in this case 6.7% is hydrogen. So what is oxygen? 32 divided by 60 is 53.3 is oxygen. So again, if you add these all up, they should add up to 100%. Okay. So now if you look at this example here, what is the percentage of water in copper sulfate pentahydrate? Our first step is we want to find what the total molar mass of this, and then find what is the mass of the 5 waters, and find the percentage composition. Okay, so the total mass is equal to, well, if we take a look at our periodic table, we have Cu, copper, is 63.5, that's 1, plus sulfur is 32.1, plus 4 oxygens, which is 64. Okay, that's the mass of just this salt. Add the 5 water molecules. So, how do you find 5 water molecules? Well, first of all, let's find 1 molar molecule. If hydrogen, each one's 1, that means there's 2 hydrogens, so it's 2 plus 1 oxygen is 16, so 18. So you're going to add 18 times 5 water molecules is equal to 90. So our total molar mass here is 249.6. So total is 249.6 grams per mole. Okay, what about the H2O? Well, the H2O is 18 times 5, which gives you, in this case, 90.0 grams per mole. So what is it by percentage of water? Well, we do 90 over 249.6 times 100%. And what does that equal to? Well, let's find out. 90 divided by 249.6 times 100% is 36.1% of this chemical is water. So why is this important? Why do we use chemical percentage composition in chemistry? Well, the key thing here is most chemicals have a unique percentage composition. We're going to find out that not all of them do. And that's what our lesson, our next lesson will be. So because of that, we use a mass spectrometer to give us the percentage composition of unknown elements or unknown compounds. Such as, for example, at airports, when they swab a bag, for example, at airports, they're looking at what is the percentage composition of the different compounds on the bag. And sometimes they can link it to certain databases that might have explosives on it. So what you're going to notice is, if you flip the page over your notes, you're going to see a graph. And this is what the graph will usually show if you run something through a mass spectrometer. Down here, these are the masses. Okay, so these are the masses. These, over here on the y-axis, these are percentages. So these are percentage. And what it's telling me is that something with a molar mass of 31.5 has 23% abundance. Something with 32.5 molar mass has 10% abundance. Something with 63 has 46% abundance. And something with 65 molar mass has 21% abundance. And that means this might go towards a specific chemical. Why is this important? Well, this is important. This is important. Oops. Important in finding the what we call the empirical formula of a compound. That's our next lesson. Our next lesson is going to be about empirical formulas. As always, make sure you keep yourself safe and healthy, and I'll see you soon.